We're almost to October. Crazy. Today is November the 26th. And we will be learning to solve equations with fractions. Did I say November? I did. I said November. I would say you don't have any proof, but I'm recording, so technically there's proof. I might have to edit that out. It's September the 26th, not November the 26th. It ended in an ember. Does that count for anything? Was I close? So I guess before we get started, we have to talk basics because the whole lesson, the whole next week will go better if we can get the basics out of the way. So one of the most essential skills here is your ability to multiply fractions with whole numbers. You'll see exactly what I mean as we get started with the lesson. So let's begin with something simple like 3/4 times 8. This is going to be a skill that just comes up again and again and again and again and again, and I don't want to have to stop every single time and re-explain what we're going to talk about here for 5 minutes. So what do you do? Right. And so we're going to always take the whole number that's part of a multiplication problem, and we're going to rewrite it so that it says over 1. Fractions like to play with other fractions. All right, someone taught you that long before you encountered me. And so now that we've gotten to this point, what do we do? Yeah, there's two schools of thought on this. And honestly, I like one of them better because it's going to be better for you. It's not a criminal offense to just multiply straight across the numerators and straight across the denominators. However, you can make your life easier if you look for reducing. And so while I'm in the problem, before I actually calculate what it is, I could look at the top floor of the hotel. There contains a 3 and an 8, bless you, and the bottom floor contains a 4 and a 1. So we have to look for numbers that can reduce with each other. Do you see any? Right. And so I would always reduce before I multiply, and I would always tell young people to do the same. If you choose to do it a different way, I'm not going to be responsible for that. So we are going to reduce before we multiply. So I'm going to take this 8 and this 4, and I'm going to divide them both by what? By 4. You could do 2, but then you'd have to go again. So I've kind of figured go big or go home. So let's take the 8 and divide it by 4, which is 2. And take the 4 and divide it by 4, and that's 1. So this one would wind up being 6 on top, 1 on bottom, which net result is 6. You'll come to like these best because they don't leave fractions behind in their wake. Obviously, that won't always be the case, but in a case like this, woo, it worked out nice. All right, let's take a look at another one. Let's say we have 2/3 times 5. Step 1, fix the 5, make it 5/1. And then we look at the top floor of the hotel and the bottom floor of the hotel. Do you see anybody that can reduce with anybody else? No. I don't either. And so this now is when it is appropriate to just multiply across the top. I used to say top, top, bottom, bottom. So if we go straight across the top, what do we get? Straight across the bottom, what do we get? And this time we're not lucky enough or fortunate enough to say, ooh, I got a whole number. This time I just am stuck with a fraction. Do not turn it into a decimal. Do not turn it into a mixed number. I'm not saying that I appreciate it. I'm telling you, do not. That's a direct order. So leave your answers, when they don't come out nice, leave them as fractions. And we use the word improper, which doesn't mean bad. Like improper behavior can get you suspended from school. Improper driving can get you a ticket or killed. Improper fractions, there's nothing wrong with them at all. It's just the word we use when the top's bigger than the bottom. Okay, let's go again. How about 4/5 of 10? Okay, So the 10, we're just instinctively going to just start doing this. We're going to put it over 1. Look at the top floor and the bottom floor. Can anybody reduce with anybody? What can they both be divided by? Very good. And so 10 divided by 5 is, and 5 divided by 5 is, and then we go top, top, bottom, bottom, and we get 8 over 1, which, wahoo, we get a whole number. We like those the best. Everybody okay with that process? Okay, so I have, I think, 6 examples for you today, maybe 9. And we're going to work our way through different sort of flavors of fraction equations, starting from what I think are the easiest up to the hardest. All right, so kind of settle in here. We got a lot. Maybe we'll take a little break halfway through. So for your first example for your notes, and there's 9. So for the example number 1, we have 6 equals 2/3 of x minus 4. I'm going to take a different approach this year. I've decided that perhaps this old dog should try a new trick. And so I'm going to take a different approach. And I was encouraged to try this because this is what the help videos on Delta Math are going to kind of look like. So if you find yourself at home stuck and have you used the little watch help video feature in Delta Math before? It has it, for the record. I pay for that. And so if you ever get stuck on a problem, you can click watch help video and it'll open a little YouTube video off to the side that you can actually watch. And this will be more in line with those. So I'm going to see if this helps. So for step 1, I want you to distribute. And so I'm going to clear all my parentheses. And so I'm going to begin by copying down the 6. And then on the right-hand side, I'm going to take the 2/3 and I'm going to distribute it through. There's another first step that I've taught before, but I say I'm going to go down a different road this year and see if you're okay with it. So let's distribute the 2/3. So what's 2/3 times x? Yeah, pretty unexciting, right? And this is why we started class the way that we did, because now we have to multiply. Get used to this. You're going to do this probably 100 times over the next 3 days in this class. You have to now multiply a fraction by a whole number. So for some of us, we're going to get there real quick. Some of you are just going to pop the answer out in your head. For the rest of us, though, maybe it's a good idea to go off to the side and actually write down the multiplication problem that we're about to have to do. And I didn't put the negative. I'm not worried. I already got the minus down. I'm not worried about that. How do I do 2/3 times 4? You put the 4 over 1. And now we look at the top floor of the hotel and the bottom floor. Does anybody cancel with anybody? No, not in this case. That 3 is pretty stubborn. And so we're going to wind up, if we go top, top, bottom, bottom, with what? Very good. 8 over 3. Now, as the problems get harder, there's going to be a different second step here. But in this problem, the next step we're going to do is what you're going to come to fondly refer to as fraction killing. I do a lot of fraction killing. That's one thing that has never changed about the way I teach Algebra 1. Fractions are bad. And I don't say that because, like, I have something against them. I say that because they're hard for a lot of people. They make us think like, oh, math is really, I hate You can hate fractions, but you have to learn to peacefully coexist with them. You have to learn how to work with them. And so we're going to deal with them. And what I mean by this is you look at your denominators. Fractions only exist because they have bottoms. If fractions don't have bottoms, they're not fractions, right? So I'm going to put on a big set of parentheses. Stop right now and make sure you're matching this. They go around the whole equation, not the left side, not the right side. And I'm going to multiply by 3. And the reason for this is because that 3 that we multiply by is going to eliminate the bottoms of the fractions, rendering them what we like, whole numbers. So I'm going to, on the outside of my parentheses, I'm going to multiply by 3. You've done this before. You've multiplied both sides of an equation by 3. You've done it dozens of times. Now, when we do this, what is 3 times 6? Okay, so the left side of my equation is now 18. And this is where, if you get lost right now, you need to speak up, because I'm going to teach you something called the hook. And the hook is pretty rad. So when you take 3 and you multiply it by 2/3, do you see that this 3 and this 3 just kill each other? Can you see that? They just cancel out. What's left over? 2x. Beautiful. Minus. Now we're going to do it again. We're going to take the 3 and we have to multiply it all the way over here to this. And yet again, the 3's just kill each other off, leaving us with what? Yes. And now 100% of people surveyed said, I would way rather solve the third white equation on the board than the second. There's absolutely no one in their right mind who says, you know, I like the second one better. Nope, not going to buy it. So at this point now, we're way back in our comfort zone and we can just solve like we always have. The equation is what we learned weeks ago. So we proceed. What's the next step? Add 8 to both sides. So we're going to add 8 right here. We're going to add 8 right here. And we're going to bring down the 2x. We're going to bring down the equal sign. And what's 18 plus 8? And what's our last step? Divide both sides by 2. We're going to cancel the 2's. We're going to get x equals 13. Put a box around it, pat ourselves on the booty, and we are done with that one. Got that? Okay. Next one. I'm going to show you how to do this problem 2 different ways. I just can't not show the other way, despite the fact that I came in here this morning as an old dog who was going to do a new trick. I will show you what I just showed you again to be consistent, but then I'm going to show you method 2, which some of you will like infinitely better. So let's stay true to what we did last time. Step 1 is to distribute right there and right there. So step 1, let's copy down the 10. Let's copy down the equal sign. And here we go. This is where the basics that we talked about at the beginning come in. What is 3/4 times 3x? And if we can start getting there quicker, that'd be pretty awesome if we don't have to show our work every time. So you picture in your mind that the 3 becomes a 3/1, nothing cancels, and you just mash them up. And right here, we would have 9/4 of x. And just as a courtesy to anyone who might be confused right now, who's not brave enough to ask, that was 3/4 times 3. I put the 3/1 and I identified that nothing canceled and just washed it through. Second multiplication problem, you're going to find similarly fruitless sort of endeavor here. Like nothing's going to cancel, right? So when the 3/4 multiplies to the 5, and I'm not going to call it a -5, I'll just bring the minus down. You think of it as 3/4 times 5/1. Does anybody cancel with anybody? No. So we just wind up with -15/4. Still good? And at this point, we should now embark, put on your fraction killing combat vest, and let's go in. What are we going to multiply the whole equation by? 4. Good. So we're going to multiply by 4. You'll notice sometimes I use square parentheses. That's okay. They serve the same purpose. I sometimes just like to use them. They look different than rounded ones, but they serve the same purpose. So when we multiply by 4 on the left side right here, what do we get? Equals 9x. Beautiful. So as that 4 distributes himself through, he's constantly pulling and cleaning the denominators of the fractions that he hits, leaving us with a super easy math problem. If what you see on the board now isn't super easy, I would say you probably weren't here for the first, I don't know, 4 weeks of school. So we're going to add 15 to both sides. And we're going to get 9x equals 40 plus 15. We're going to divide both sides by 9. And what do you think about 55 divided by 9? It's just going to be a fraction. It ain't happening, is it? You can't divide 55 by 9. They're not in our divisibility sort of realm. So we're just going to go, well, since I know you can't divide, you're going to be a fraction. Can 55 and 9 both be reduced by anything? No, so our answer is just x equals 55 over 9. And that is that. Yay! That's it. Light bulb. I'd like to show you another method to do the same problem. I would say that almost probably at least 50% of you are going to like this method better. So here we go. I'm going to copy the same problem down on the right side of this curtain. And what this method is earlier fraction killing. This is getting in the way of the fraction before it distributes itself. I look at a fraction like a virus, and you say to yourself, like, would I rather kill the virus early, or would I rather let the virus spread and then kill it later? Obviously, less work if we kill it early. That's a no-brainer. So what I'm going to do right now is I'm going to kill the fraction immediately. I'm going to put this entire equation in a set of monster brackets, parentheses, and I'm going to multiply by the fraction killer, 4. So what happens now is when you multiply the 4 here, what's 4 times 10? We get 40. That's going to look familiar to you, but this is the part that I think you might find attractive. Again, I want to say we get in the way of the fraction before he does his evil bidding. The fraction's like, I'm going to spread and make more fractions. And if you get in his way, right here, what's the result of that second red arrow? It's 3. And so you're left with just a 3. And then the stuff in parentheses is protected and it just drops down. You see? And that fraction, that multiplication that I did up there in red, that cannot penetrate inner parentheses. And so that's the beauty, is that basically it just hits the fraction, the blocker at the door, like the bouncer, and then it's dead. It's taken care of. And now you'll see here in the next step that we just distribute, but we're distributing a whole number this time. And that's why this might be a more attractive method for you. So we have 9x minus 15. And I would say from here, you're probably not paying attention if these two things aren't looking familiar. So from there, you would proceed as normal. So those are your options. You can kill the fraction early, or you can kill the fraction late. Doesn't matter to me. Which method, just out of curiosity, do you find to be more enticing? First or second? Second one? Get rid of the fraction early? Okay, well, then I'll do it that way again. So let's do it. We're going to do -8 equals 1/2 times the quantity of 4x minus 6. So let's do some early fraction killing on this one. What are we going to multiply by? 2. Very good. And the first distribution is right there. Boom. What's 2 times -8? -16. And this is where the good stuff happens. Right there, what's 2 times 1 over 2? So I want you to look up at the television real quick and take note that I did not put 1 there. Why wouldn't I do that? Yeah, because what's the point, right? So if you put 1 and then you just turn around and distribute 1, you're literally wasting time at that point. So if we're fortunate enough to kill a fraction whose numerator is 1, the top of it winds up serving no purpose, and we can just say, bam, just like that, poof, presto, we're there. Good. And then from here, I would imagine you've got this like on autopilot. We're going to add 6 to both sides. And we're going to have 4x, bring it down, equal sign, bring it down, -16 plus 6, divide both sides by 4. And you get a fraction, obviously, because, you know, you've known for years that you can't divide 10 by 4. So we get x equals negative. Just put the negative so you don't do something stupid. 5/2 is the proper way to say it. You can say 5 over 2. I like to sometimes say 5/2 because that's not proper, but it's fun to say. So any questions on that? That's like level 1. Okay. So in your notes, I don't know if you really want to, but you could do something like draw a line, and that line will signify, okay, here comes a new flavor of problems. These are all going to look characteristically different, you'll see. This problem will freak you out for approximately 25 seconds. And then after we kill the fractions, as has always been the case, kill fractions and we are immediately back in our comfort zone. 100 out of 100 people surveyed who said they're scared of this problem answered it's because of the fractions. So let's get rid of them. Let's make our lives easier. This time we have multiple fractions. What do you think we could multiply by that would kill them both? The common denominator, which is? Nope. Certainly not 2. I see you guys are a little rusty on your common denominators. The least common denominator is 8. You have to remember that a least common denominator is called a multiple. It has to be at least as big as the biggest denominator because it has to kill them both. You're thinking of something called a factor when you say 2 or 4. We don't want that. So we're going to multiply by 8. Now, when we do this, we're going to really embrace that hook that I talked about. You're about to potentially get lost, and it is totally your responsibility to own that and admit it and raise your hand or don't and say something like, I don't get how you got that. So here it goes. We're going to use the hook. I call it a hook because the way it patterns, I don't fish, but I've always pictured that this kind of looks like a fish hook to me. I don't know if you agree with that or not, but it just looks like a fish hook. It looks like something I would tie on some line and drop it in the water and it would hook a fish. You see that? So I've drawn an arrowhead on it, not to make it look like a hook, but because this is the pattern that I need you to follow. You ready? So I'm going to do 8 divided by 4. That's how the hook is going to work. We divide down and then we multiply across. Divide, multiply. What is 8 divided by 4? So I'm going to have a leftover 2 that is going to multiply by what's on the top, 2x plus 3. If that was hard for you, don't worry. We're going to practice it lots. Then we're going to hook again. So again, we've accomplished this multiplication by the hook. Now let's do the yellow multiplication. That's here. When you do the hook, what's 8 divided by 8? So that's a clean kill. So I can just put plus 3x minus 2. Because it was a clean kill, there's no one left when we're done. So we don't need to put 1 there, obviously. And then finally, we're going to do the green multiplication, which is all the way across. This one people forget all the time. It's a little weird. What's 8 times negative 3? And just like that, the fractions are gone, and the equation is now a pleasant little non-scary, wimpy entity. From here, what do? Distribute. So we're going to get 4x plus 12, plus 6, excuse me. My bad. Plus 3x minus 2. What's the next thing we do? Add like terms, specifically the like terms that are on the same side of the equal sign. So like this 4x and this plus 3x make 7x. This plus 6 and this minus 2 make plus 4. Everybody still okay? You saw it to be cruise control for you. We've done so many equations. What's the next thing we do? Yep, we're going to do minus 4 on both sides. And we're going to wind up with 7x equals. Last step. And we're left with x equals, is it good or bad? It is. This is a nice one. We get x equals negative 4. Any questions on that? Next one. It's all about the first step, baby. If you can get rid of those fractions and you don't do anything silly, then you've proven to me that you are great equation solvers. But the fractions are a new twist. They're a new annoyance that we just have to deal with before we can actually go. What is the least common denominator of 6 and 8? If this were fourth grade and you were going to add two fractions together that had bottoms of 6 and 8, what would you turn them both into? You could use 48, but I'm not going to because it's not the least common. 24 is the best one. You would agree that 6 and 8 can both turn into 24? It's the smallest one they can both turn into. That's what I will use. And so my fraction killer is going to be the number 24. So here we go. When we perform the first distribution, that is this, I'll do it in red right here. Do the hook. Hook, 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 hook. What's 24 divided down by 6? And that leaves me with 4, and then times whatever's on top, 4x minus 1. Do not skip this step. This next one will be a little dangerous. So here we go. 24 divided by 8. Very good. And so this one I'm going to do in yellow. And I want you to notice something, that there's a minus sign right here. That's been the death of many, many math grades over the years. So watch out. When 24 divides by 8, you get 3. But I'm going to put it as a minus 3. And then it's going to multiply by x plus 3. Anybody get lost on that part? And then we sometimes feel so accomplished that we stop and we just write equals x minus 2. No, no, no. What's the green answer? 24. Equals 24x. And finally, still don't pat yourself on the butt. You got to multiply 24 all the way over here. And what's that? There you go. Are the numbers big? Yeah. Are we scared? No. Now we're just going to do what we've done. We're going to distribute, combine like terms, and solve. You've done it 100 times. So on the left side, let's distribute. What do we get? And what's the yellow part going to give me? Watch out. Okay, I need pluses and minuses. I need minus 3x, and what else? Minus 9, because that's a negative 3 distributing to a plus 3. It's going to change his sign. Equals 24x minus 48. And we're one step away from that spot where we look at it and go, that's a piece of cake. Let's combine all the junk on the left. What's 16x's minus 3x's? Where? This is a positive 24. You okay? Okay. So when we combine, what is 16x minus 3x? And what's negative 4? Or you can call it a minus. I don't care. Minus 4, minus 9. What do you get? And it's at this point that you realize now you look like somebody that I know. We're going to get the x's to one side. We're going to get the numbers to the other side, and we're going to divide. So here we go. We're going to begin by subtracting the 13x from both sides, because we know that we should control the x's while we can. So we're going to be left with negative 13 equals how many x's? 11. Then we're going to do what next? Add 48 to both sides. And we're going to be left with 11x equals what? Help me with my math. What's negative 13 plus 48? Positive 35. Good. And then we're going to divide both sides by 11, leaving us with, does the division work or no? This is a no, and 35 and 11 are what we call relatively prime. Means they share no common factors other than 1. So we just take what we get, put a box around it, pat yourself on the booty. Good so far? Okay. I'm going to skip an example here so we can get on to now level 3. So we're going to head to the third tier of difficulty. This is usually where the stress starts to pop up. So you've been warned. 2x minus the quantity of 3x minus 3/4 equals, man, it's warm in here this morning, 4 plus 2/3 times the quantity of x minus 6. I'm going to go I'm going to contradict something I said earlier. You guys all seem to take a liking to the early fraction killing. You can actually do it here. Here's the trouble. This is going to take 2 waves of fraction killing, if you're interested. Because the parentheses, you see the 3/4? I know you see him. You're looking right at him. This guy is mocking you. He's giving you one of these nanny boo-boos because he knows that when you sweep through this equation to kill fractions, he is safe for now. So if we're going to go this route, we can ignore the fraction that's inside parentheses and let's go early fraction killing. The fraction that's in our sights is this guy. Only fractions that are out in the open and exposed can be killed. So what are we going to multiply this whole equation by? Very good. We have entered the zone now officially where the trouble starts. And so just please be open with me and honest and don't be embarrassed. If you need me to stop and explain something, please ask. We're going to multiply by 3 because that will kill the only fraction we can technically see. So here it goes. Right here, what is 3 times 2x? Yes. Now watch out. There's another distribution right here. You see how there's a number in front of those parentheses? What is that number? Yeah, there's a -1 sitting right there. I just made him yellow for you. So we're going to have -3, and then in parentheses, 3x minus 3/4. Now we have a blue distribution to do. That one's easy. What's 3 times 4? And then we're going to do a green distribution, which is all the way across to here. And of course, the reason we're doing this is because what we're about to get. What's 3 times 2/3? 2. So we have plus 2 times x minus 6. You see that yellow fraction? He's still nanny boo-booing us, and our only option at this point is to distribute the -3 and pull him out. So you can only do what you can do. Only fractions that are out in the open can be killed, so we need to get him out. So now we're going to do a step of distribution. We're going to copy down the 6x. What is -3 times 3x? Yeah, got to be real tight with your words. Every minus and plus matters 100%. And what is this distribution right here? I need you giving me pluses and minuses every time. So plus 9/4. Good. And then on the right side, I'm going to copy down my 12. And then when I distribute that green 2, what is 2 times x? And what is 2 times -6? Minus 12. Good. So at this point, you're separated into one of 2 groups. One group who you're kind of scared of fractions, another group you might say, I'm okay with fractions, and you might find an alternative way to do this. For me personally, the guy who gets to teach this to 50 people all of the same day, I'm going to kill the fraction. It's worth it to me. So I'm going to take now. And by the way, you can look for obvious things. Do you want to do a little cleanup work before we fraction kill? I think we should. Yeah. Do you see this 6x and this -9x? What do they make? So let's go ahead and put those together before we fraction kill. That'll save us just a little bit of time. And then on the right-hand side, I assume you see that there's a 12 and a -12. What do they make? 0. So the right side is just 2x. Jumping in and doing some cleanup work is pretty smart. And now it's time to fraction kill. So we've done 1, 2, 3 steps, and now we actually have to solve the equation. So what are we going to multiply by? 4. Very good. So let's multiply the whole equation by 4. What are the 3 answers going to be now? What's my equation going to say? Perfection. And now all of its bark is gone. Not scary. Normally, I would be very proud if you said, let's add 12x, or actually in this case, that is the right answer, isn't it? So let's add 12x. Got ahead of myself there, but actually that works out nicely for us because we got to get the x's over to the right. So we wind up with 9 equals 20 x's. And what do we divide by? How's the division going to be? Nah, no bueno, right? And so we're going to have x equals Oof, there you go. You guys doing okay? Sorry, it took longer than I thought, and I'm not done yet. So you're hanging in there. You're doing great. Couple more. This really presents itself, if what I said earlier makes any sense. You have two fractions right now that if you distribute them, you could potentially wind up with 4. So why let the fractions spread and create more evil when we could jump right in right now and eliminate them? So here we go. I have two fractions that I need to get rid of, and their bottoms are 2 and 4. What is the least common denominator of 2 and 4? So we're going to monster bracket this whole equation, and we're going to multiply by 4. Ready? When we do this first multiplication right here, and we embrace the hook method, what's 4 divided down by 2? And then you take that 2, you swing it up around and multiply it by what was on the top of the fraction, resulting in -6. And then remember that the multiplier does not penetrate the parentheses. So I'm going to switch colors now. Let's go blue. What is the blue answer? -4x. And now I'm on to yellow. What is the yellow answer? Good. That was a clean kill, right? The 4 is just poof, gone. So we don't need to do any of the fancy multiplying there. 1s are pointless. And then finally, I'll switch to green. We'll head all the way across. And woof, what is that? So not all problems are created equal. Sometimes it takes a couple of minutes to eliminate all fraction annoyances. This was one-stop shopping. And from here, you should be on cruise control. What do we do? Yeah, so we get -30x plus 42 minus 4x equals 6x minus 15 minus 16x. What do we do after this? Clean up. Combine like terms. -34x's plus 42 on the left, and on the right side, -10x's minus 15. And it's just yet another basic 3-step equation, right? Okay. So add 34x. You guys okay with that? Good. And so, you know what? This is something, I don't know if all of you have gotten on this bandwagon yet, but it's okay to do 2 steps at once. Some of you just kind of started doing this without me telling you, which is pretty cool. If we're going to add 34x, then we can also, while we're here, add the 15 back across. It's like a double whammy, right? It gets you to where you want to be and just saves a little time. So I'm going to cancel out my x's on the left. I'm going to cancel out my 15s on the right. And I'm going to get 24 x's over here and 57 over here. Nice, huh? If you haven't started doing that, it's a nice time saver. Good? Good? And then if we divide by 24, what do you think about the division? No bueno. However, it can be reduced. So we wind up with x equals 19 over 8. And in case you're wondering how I got that, I divided the top and the bottom both by 3 because I could. How'd that one feel? No, well, I could tell the sneeze was good because you were like, oh, cool. That's a good sneeze right there. That's a therapy sneeze. Yeah. All right, let's do one more and I'll show you. I'll do this one a little bit of a different way just because this way here, I'm not just teaching to one style, but maybe some of you would like this better. You will get good at these by just doing them. these obviously will all be done on paper. Shouldn't have to say that. So if we right now swept through, what would we multiply by? Nope. Nope. 15, because there are two exposed fractions whose common denominator is 15. I'm going to take a little bit of a different approach, not to be Mr. Inconsistent here, but some of you, again, might say, I liked this. And so rather than killing fractions right now, I'm just going to say, nah, I'm in high school. I'm going to distribute. So right here, I'm going to distribute this negative. What do I get? The good thing about this method is that it gets all fractions guaranteed right out in the open where we can kill them. Never have to do like the multiple fraction killing steps. And here's what we started class with today. So watch out. Oh, don't be, you got this. What is negative 2/3 times 4x? Yes. That's scary for some people. And right here, what's negative 2/3 times 9? Did you mean negative 6? So in case you got lost, we just did 2/3 times 9 over 1. And when you reduce it down, you wind up with 6. And look at that. Oof. So you see over here on the right-hand side, you got like terms. What do those make? I'm underlining them in yellow. What do they make? So maybe I could just put those together to make minus 12. Now at this point, you do want to fraction kill. What are we going to multiply by? So here we go, monster brackets. We're coming in. Bam, 15 is our guy. There are 5 multiplication problems that all have to happen here. What's 15 times 2x? What's 15 times a minus 1? And here is where the fraction killing happens. I'm going to draw a little blue arrow. Watch out. Right there. Do the hook. What's 15 divided down by 5? 3 times 4? Bam. So we're going to just put minus 12x. Man, that's cool. And I'm going to draw a little green arrow this time. Second iteration of fraction killing, do the hook. Hook it. 15 divided by 3 is 5 times negative 8 is bam. And again, I'm telling you from years of experience, a lot of times people get so excited. They're like, look at me killing, and they forget to multiply. Don't forget to finish the job. What's 15 times a minus 12? I got you. It's 180. I don't know what I was writing there. If you wanted to, yeah, you could have fraction killed early. Then your multiplication would go here, 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 and here, where the yellow arrows are. Okay. What are you talking about? It's right there. See it? Good. Sorry, my bad. All right, let's finish this off. You guys are just sick of hearing me talking. I'm sorry. It always takes longer. This is a big, big lesson today. So how many X's we get on the left? 18. And on the right, well, that's pretty unexciting. There's nothing to do. So what should we do? I'm going to add 40x to both sides, which is going to give me 58 x's. And then I'm going to add 15 to both sides, which is going to give me negative 165. For the first time ever in your presence, I am not showing work. That's going to be something that I start to allow more and more at this point. First time you screw it up, though, from not showing your work, I'm going to make you go back and show it again. So. And then we're going to divide both sides by 58, and we're going to wind up with a final answer of x equals negative 165/58. And that's that. That's a lot. That was with one example skip. So congratulations, you survived that lesson. I'd like you to spend 5 minutes now. I want you to go dive into your new Delta math assignment, and let's just see if we can maybe knock out a couple. Tomorrow, I say, is a full work day. Uh-oh. Look at that. My lecture was so long, I broke Zoom. I have created your assignment so that it's a mixed bag of the different levels that you learned today. So you're going to just randomly encounter, and I set the likelihood on all three levels to be identical. So you're not any more likely to get a hard one than an easy one, whatever you ability, luck of the draw. If you don't have scratch paper on your desk, I am going to totally get on you about that. I'm not going to leave it optional. Like, wow, good job. You can do these in your head. That is not happening. So you are required to have paper and a pencil and probably a calculator if that's your thing. You must use paper. As always, your problems are all different. So like I said, it's luck of the draw.